This is video 3, and what we're going to look at is setting up final board. In the meantime, we've calculated the cable sizes, so we went up to display, calculate all, and that's calculated our cable sizes on here. So what we're going to do is access DB1, double click on it. This brings up the load entry details where we have our load and our power factor. To access the board, we go into the Ways button. This brings up the general information for this board. I'm going to tidy up that reference, and we can put the description. Number of ways. This is where you set the phasing arrangement. So if you have a mixed board, or you want to set up a split board where you might have some three-phase circuits, then you would leave the board as TP&N, and you would change phase, which we'll show you in a bit. Maximum board rating isn't critical, but that might be the manufacturer's rating of the board, which you could enter. Distribution board sections for a split board. I'm going to show you in another video how to set up a split board. We'll keep it simple to start with, and we'll set up the single board. So there is the short circuit fault level, earth loop, and the voltage drop. And here we have the preferred switchgear device. So in Edit General earlier on, we said all our final circuits are going to have IC60H type Bs, 2 to 63 amps, rated at 15 kA. So we shouldn't have any problems because the supply is only just below 15 kA. You can alter the size range, so if you wanted to look between a certain range of devices, you can set the minimum and maximum sizes as well. Premises location determines and is used for the diversity. So for example, at the moment we've got other selected, which means we can diversify at group level, lightings, sockets and cooking. So if you had an office block and the majority of your offices have daylighting control, you could apply diversity, and then on any areas where you don't have daylighting, you could then switch off the diversity on individual circuit level. So you can diversify at group level by selecting other. You can diversify each individual circuit if you wish to. That's an option available when we add our final circuits in. And you can also diversify the board at board level. So don't do all three, elect to do one of them, otherwise you'll get yourself into trouble. I always like to diversify final circuits only, and that keeps it simple then. You imagine the issues you might have if you diversify final circuits at group level and at board level. The cables are grossly undersized. So we'll keep it simple and just set that to 100. There are other types here: dwelling, shop, office, small hotel. Those will automatically use the diversity to 18th edition. Medical will give you, depending on the group of the space that you're applying. Question mark gives you the PDF sheet showing you the different types of space. So a massage room has a much less high level of diversity requirements and disconnection times than you would have, for example, in an operating theatre. So these set the safety class systems in terms of disconnection times, etc., on the specific circuit that you're looking at based on the grouping of the space. We select OK. This then sets the board up for us, where I'm going to set it up as a TP&N because we're going to mix them, as we said earlier on. And this then sets the board up with a mixture of ways. So the first thing I would do is split up the board into its component parts. And you can see here up on the final circuits, you've got copy ways, move ways. So we'll look at these later, but the one of interest at the moment is change phase. So I select change phase, and on the command line in wiring, always keep an eye on the command line in the bottom left corner, click inside the way to alter. Click on it, single phase, that breaks it down to L1, L2, L3, brown, black, grey. Continue, because the command is active all the time, until you've decided on the way the way you want to split your board up. Once you've finished, press escape, that cancels the command, so you're now able to then go in and start editing your circuits. Now if you want to go back to the general information to make any changes to the board generally, there's two choices. You have Edit General, which brings the board detail back, or where you have this reference in the corner here, double click on it, that also brings up the general information. And this is where I'm talking about later on stretching the board. You can see as you build up the references, sometimes you need to stretch the board to make it further. So what I could do, I could exit final circuits to take me out of final circuit mode. And you can see here it's demanding that I have a load on there. So what I'll do, I'll do that when we finish the board, because you can't exit. I could enter a dummy load on there, stretch it, come back in, but I'll just carry on back to the ways on the board and we'll continue. So you notice if you try and exit the board with no ways on it, so if you're trying to set up carcassing on a job where you just want to set all the ways up and get the skeletal structure of the job done, you have to put a load on the board just to get out of that dialog box. So we'll start off with some lighting circuits typically. So double clicking on the way gives you the description, and you can see here you have the description. You can't have a description called spare because that's the default, and you have various types of way entry available to you. So for example, lighting, special socket. So we'll stick with lighting, and I'll call this Office 1. There is a limit to the number of characters text-wise, so don't put lighting Office 1, because what it's going to do, whatever you type in the description, it's going to put a prefix of LT to represent lighting, or SRI for ring main, or SRA for radial. So don't waste text by typing lighting Office 1. Office 1, it'll put LT in front of it. You know what it is. You're not wasting text. So the way details are broken down into 3 areas. You have your load details, your cable details, and your switchgear CPD details. So we'll go into the details option here. There is a range of older type light fittings, all sorts of different light fittings in here. You might want to go for an LED, which most people do these days. You can then put the rating of that. So let's say we had a 50-watt track of LEDs and we had 4 of them. That gives you your subsequent load on the way. And this is where you can apply the individual diversity on the circuit. So at the moment, we're not applying any diversity at all. So if this was actually an office where I had daylighting controls, I probably might want to untick that box and say, okay, we've got a row of lights by the windows. Let's give it some diversity. If it's a bath or a shower area, then that would facilitate the means of an RCD from the regs. So it would warn you that you don't have an RCD in here if you click the bath and shower. Clicking that box will mean you do get an RCD, which these days are commonplace anyway. We then go and put our cable length in. So it's a 25-meter run from the board. There's our cable type, our installation method. And again, the details, similar to the submain where you can control your CPC, you can fix your cable size and go in and derate based on your groupings, temperature factors, and again, derating to the IET method. So the same applies at final circuit level as its submain as far as controlling your cable. Notice this is PVC singles, so supplementary is grayed out. There is no supplementary on a single on a separate CPC type cable. So these options are grayed out in accordance with the cable type. And there you can see the table. So having put the load and the cable length details in there, there's the default device which I'll stick with. I can then run the results, and that gives me the results. It gives me the cable CPC size, 2 singles. It gives you the max length you can go up to before you go up to the next cable size. So if you did fix the cable at 1.5 meters, this means you can go right up to 543.4 meters before you would have a voltage drop issue. So I think there's some scope for rerouting a cable on there, no problem. CPD type, size, fairly self-explanatory. These are your voltage drops and your power factors, and of course your short circuits and earth loops on here as well. Okay, in this circuit, now I might have a situation where I've got lots of offices that are the same, or lots of spaces that are the same, or whatever. I can copy these, so this is where the copy function comes in. So copy ways, click once on way 1, click once on way 2, click once on way 2, click once on way 3. You can carry on that basis, copying your circuits. Pressing escape, and then what you would do is merely go in, change the reference, and you might change the cable length as you go along the corridor away from the board, for example. So all of these references can be changed. As I said earlier, notice the reference of LT as the reference prior to the reference on the lighting circuit, just to show you what type of circuit it is. Of course, you don't have to just change the reference, you can change anything on here as well. There is a different type of display on here. In display options, this gives you the option to show different outputs. So I've got my CPD symbols. I might want cable type and size, loads and CPD type, four-way types and descriptions. So you can show different results. And as we zoom out, so if I go and say view, zoom out, you can see you're getting your descriptions on there. Cable. One thing a lot of people do is tend to get themselves into a mess. We're in final circuit mode, but you can still zoom out because you can copy away from one board to another. So we are technically still in final circuit mode. So the first thing people might want to go and look at is say, okay, I want to edit this cable now. So they'll double click on the cable. You can still get the cable entry details, but you are still in final circuit mode. You can always tell whether you're in final circuit mode. If you go to the edit menu, if you've got this final circuits ribbon up here, this means you're in final circuit mode. If you want to do anything like a main calculation or go out and edit the transformer or anything like that, you would need to go out to final circuit mode. And we'll do that when we exit the board at the end of this video. So I'm still in final circuit mode at the moment. So I'm going to now enter a load on way number 2. So I'm going to put a ring main on there. So if I double click on way number 2 L3, that takes me back into the board and into ways. And then what I can do is go in and double click on that way. So double clicking on way 2, I've now got the ability to go and put a standard socket in there. And I'll call that, let's say those offices have a ring main. The length of the ring main in. Go to details. So there's no order which you can put these information in as long as you enter the details. The order doesn't matter. So that's telling you immediately, built into the regs, you must have an RCD of 30 milliamps or less on this type of circuit. So we go into the circuit details and we put in our socket type. We can put the fact that it's going to be a ring main. And again, we can diversify. At the moment, we're 100%. So if I put 32 amps in there, 32 amps is what I'll be getting. I could put 32 amps in there and then untick the box and say, right, I want 16 amps, which would be 50% diversity. Or I could actually put the full load in there with it. Or what I could do is leave that at 100%. And then come in and put the actual envisaged way load in there. Let's say not 16, 18 amps. So you can either estimate the load as a current rating, or you can put the full load in there, tick the box, untick the box, and apply the diversity. And then for quantity takeoff purposes, we can put the number of single and double sockets. So if each of those office had a single and a twin socket, we can apply those accordingly. Notice regulation 411.3.3 RCD exemption. If circuits are exempt, you can tick that box and that won't then apply an RCD. Now the regulations do change, so in a year's time when you look at this video, things may be different. I know things are changing for the 18th edition as we speak in July 2021. There's a new 18th edition, so that may well change, and if it does, we will act accordingly in that little description there. So at the moment, you can exempt that circuit, which means you won't put an RCD in and it won't insist that you do. There you go. Circuit requires a 30 milliamp or less RCD. So I could put an RCBO in, or what I could do is go into the details. I can simply come into here, RCD generic, and make sure it's at least 30 milliamps. And that then tells me I've got a failure to discriminate. We'll look at the discrimination issues later on. We won't clutter up this video with these issues. As we build the network up, we're bound to get problems, and I'll explain how you get around them. And because we have a discrimination issue, that's a problem circuit. That is highlighted in a dotted line. You can see there, dotted line equals problem way. In fact, while we're here, let's go and have a look. So what I could do is a discrimination study. Display discrimination. Selecting the circuit back up through the system. That shows me my discrimination curve. So there's a good idea of where we can see a typical. There's my first device there. There's my breaker number 2. So I've got a IC60 type 4 on the final circuit, yet the board is only rated at 25 amps. Now at the moment we have been out of the board and come back in again, so that doesn't really reflect what's going on, because by the time we exit the board we will have the correct full load on that board. Things will change, because once we've got the full load on the board based on the circuits we're putting in, that will increase the size of the device upstream and this problem will go away. So this actually is probably a good example of what not to do. Don't try and solve your problems as you're building the board up, because if I then go and try and mess around trying to get these to discriminate with each other, to not discriminate with each other, as I build that board up and the load increases, then I'm only going to have to mess around later on with my upstream device anyway. So it's always best to let the problems occur. You should really only be solving your problems once you've completed the complete project, Obviously, as you make changes upstream, different fault levels have a bearing on the ratings of the devices and whether they're good enough for the rating at that point in the system. So don't bother trying to solve your problems when setting up the project. Once you've completed the project, if you've got any red cables or dotted lines, then that's the point at which you solve the problem. Now, I noticed here I was talking earlier on about stretching the board to do printouts. You can see here I'm getting a bit of overlap here, a bit of overlap here. It looks a bit untidy. So what I'm going to do is exit Final Circuits and then go back into Overview mode. So if I exit Final Circuits, that takes me out to the overview. Select OK. And what I can do is grab the board, stretch it a little bit. In fact, I'm going to view home. So you can see there you've got a red board. Red board implies a problem. So as you're building your circuits up, I mean, obviously we know we've got a problem on that board because we are actually in final circuit mode. But if you were building up a project and you run the calculation and suddenly boards go red, that implies there's a problem. So again, we double click on the board, we go into ways, this takes us into final circuit mode, and notice now the problem's gone away because now it's looking at the full load on the board. When we display calculate all, that's now rectified that problem. So before we had a board with 25 amps on it, which was an incorrect rating because we put this 32 amp ring main on here, but now the board is updated, that problem goes away. So that's a typical example of why when you're in a final circuit, you shouldn't try and solve your problems unless you've completed the project. Just run with the problems, finish the project, then sort the problems out. So another typical circuit we could put in, let's have a look on the list. Stationary equipment, there are others, we won't cover them all because they're all fairly self-explanatory. Stationary equipment is a good one because this can cover a multitude of sins. We've got all sorts of different equipment in here. We might have underfloor heating, we might have a water heater, motors. So you can select the sort of appliance you want, let's say heating and power, put the current rating in there, power factor. If it's mobile equipment, then it will insist on an RCD or a VA and a power factor. So you've got your VA, current ratings, you can enter that again with diversity on there as well, and then putting our cable length in there, running the results. That's telling us we've got a ZS issue. So again, I wouldn't bother resolving that until I've finished my project. Okay, that, and of course it doesn't allow you to have a reference to spare. You can see it kicks up a message. It doesn't like the word spare. Call it spare full stop or spare one or whatever. I'll call this UF underfloor heating. Again, there's that dotted way which we'll ignore. These days a lot of EV chargers going in, so let's stick an EV charger in. We're going to and then we can go in and put in a charging socket. Go into the details. There's your various charging points. So we'll go for one of these types. More familiar. Actually, we'll go for one of these. This is what you're used to when you plug in your Tesla. Sticking your current rating in there. You might be using a main earthing rod. You might be using a main earthing terminal. Okay, that. So it says the load must not be greater than the 16 amp mode for EV sockets. So as you see, there's all sorts of built restrictions in here based on the type of socket you're using. So I need to go to this little down arrow and select a 32 amp. Okay, that. And I need to enter a test value because obviously these need to have a separate electrical earth load on there. I'm going to check on that. That passes the test. We can OK that. And put our length on there. Results. Okay, we've got a problem on there as well, which we would look at solving once we finished our project. So it's more of the same on here, adding circuits. So we've given you a good flavour of how you enter the final circuits. You might want to balance boards up. I mean, you can swap ways around. You've got these options here: move way, swap way. So if I want to move away from there to there, I can do so. I might want to then swap ways. So first of all, I'm still in the move way command, so I would press escape. If I want to swap ways around, I would go and swap ways and say I want to swap that one with that one. and that swaps them around. That one and that one. Move ways. I'll move that one back to there. Escape. So it allows you, when building a board, you can start balancing the circuits up if you wish. In setting up the board. Resetting ways will basically reset them to their default value. I won't do that because what it'll do, you'll just end up with one of these blank ways. So it's basically scrubbing everything on the way that you've got there and starting from scratch. So that basically covers setting up a final board. So what we'll do, we'll exit final circuits and take us back to overview mode. There's the load on the board. Display calculate. It's not a bad idea to calculate your system as you build it up, actually. If you notice that board is still red, of course, as we set the system up later on, things might well change. Exit final circuits. So there we are. So that concludes video 3 about creating final boards.